Hey everyone, just wanted to share a quick, hopefully helpful video on how to attack worksheet 4B. All right, so this is worksheet 4B. First off, please read the introduction section. It's a few pages, but we're showing you how to do the different types of problems you might encounter. So please at least glance through there and make sure you understand each of these issues if you can. So once you've done that, then go ahead and dive into the rest of the exercises. And that's what I'll do, a few of them as examples for you, show how it goes, and give you a couple of little pieces of advice along the way. So first off, this first bit is just trying to introduce you to the metric system or get you to remember how the prefixes work. So this is basically just copy this over from some other information. So where would you get this information? Well, you can look up metric system prefixes online. They'll show you. You can fill in what each of these things are. For example, the K is for the metric prefix kilo. And that prefix means 10 to the third power, or 1,000. So in this equality over here, what we're saying is if you put the K there, so 1 K, kiloliter, is the same thing as saying 1,000 liters, or 10 to the third power liters. The K is equal to 10 to the third power. And that's how metric prefixes work. So you can Google it, you can look metric system prefixes, but I want to suggest a couple other things. First off is your textbook. So online or in person, your textbook has these conversions at the front of it. So here's a bunch of them, here's some, and then interspersed throughout there will be tables with different conversions on them. So that's a good choice. Conversions are super important to chemists. They always start books with conversion tables. Maybe not always, but very, very often. Second, if you were on campus, we'd be pushing this yellow sheet on you. So we've been collecting conversions that are very common in chemistry classes on this yellow sheet over the years, and we try to give them out to every student that we ever see. But you're not on campus this semester. So what I'm going to do is I'm going to email out a PDF of this. You can print it, and I think it's a great thing to just have on hand. One side of it is a periodic table that has good precision on all of the masses, also electronegativity, so a lot of useful information here. And the other side is the conversions. So I recommend printing this out and keeping it next to you for really this entire class, or just post it up on your wall or something like that, wherever you're doing your work. So that'll get emailed to you soon. You can print it out if you want, use it on your computer if you want, or use your textbook, or use online. But I really don't recommend online as a general rule, because Google knows how to do most of these problems for you, or many of them, and you won't really be learning anything. So that won't help you when it comes to exam time. Whereas having a handy sheet like this next to you come exam time is really the type of skill set that you need to develop to do well on that exam. All right, so just go down the sheet then, and here we've got the metric prefixes listed for you. So you see the next one is C. You come over here and see that C is centi, and that means 10 to the negative 2 power. So C equals 10 to the negative 2 power. We pronounce it centi. So 1 meter, oops, it's reverse. 1 centimeter, the letter always goes on the opposite side of the multiplier. Because remember, C, that letter C is equal to 10 to the negative 2. So 1 centimeter is 10 to the negative 2 meters. So keep filling that out, and then go on and learn how to use it on the next pages. So let's do a problem. Let's convert kilometers to meters. So we have that conversion from the previous page. Go ahead and flip that over so we can see it. We know that kilo is 10 to the third power, kiloliters, 10 to the third liters, and that works the same way with meters. So we would just write multiplied by there, and we need to put this conversion either side. So we know that we have to cancel that unit. So we're going to put kilometers on the bottom, and it says that we're trying to get meters in the end out. So we're going to put meters on the top. And now we just need to know where to put the multiplier. Well, remember that the little lowercase k is equal to 10 to the third power. So wherever you have the k, put the multiplier on the other side. So k, kilo, is equal to 10 to the third power. So 1 kilometer is equal to 10 to the third meters. Kilometers cancel. 5.2 times 10 to the third power will equal, you could write it in as 5.2 times 10 to the third power kilometers in scientific notation, or you could write it in as 5,200 kilometers. Both equally correct answers. Okay, so moving on. That's how metric prefixes work. That's how you use them in conversion problems. Moving on, let's find some new problems. So that's when you have just metric system prefixes. What about when you're going like within the English system, or from the metric system to the English system, or from the English system to the metric system? So here's a good example where we're converting grams into pounds. So we'd start out with 2.37 times 10 to the fourth power grams, and converting that into pounds. You need to end up at the end of the day with our answer in pounds. So can you convert directly from grams to pounds? You can, but we need to make sure we have the conversions to do that with. So we're looking for conversions to get us from grams to pounds, and you come over here and you look at your conversion sheet, and here we do have a direct conversion. 1 gram is equal to 0.02204 pounds. If you didn't have that, then you just have to find out what you have a conversion from grams to. For example, you might be able to convert from grams to kilograms using metric system prefixes like we did in the previous problem, and then convert from kilograms to pounds with a kilograms to pounds conversion. We have the direct one, so we'll use that. So we'll come back over here and we'll write it in. The conversion is 1 gram is equal to that many pounds. The grams is on the top here, so we need the grams on the bottom to cancel. 1 gram is equal to 0.02204 pounds. Our grams cancel. We've ended in pounds, which was ultimately the unit that we wanted to end in. So now we can just go ahead and plug it into our calculator. So the calculator that I just happen to have with me is this one. So the way I would plug that in is I would plug in 2.37, and then for the times 10 to the fourth power, remember that we need to be using our EE button for that. So whatever calculator you have, it's usually EE if it's on a TI, a Texas Instruments calculator, or sometimes it's EXP, or on some calculators like this one, they actually have a times 10 to the power of button. So find that and make sure you're using that. So we're going to type in 2.37 EE times 10 to the power of 4. Now that's not an exponent. This calculator knows that that's times 10 to the power of 4. Then we're going to go ahead and multiply it by this. We don't have to divide by 1 because anything divided by 1 is just itself. So times 0.002204 equals, and there's our answer. 52.2348 pounds. Also, when we're working from home, you get to hear my daughter and my dogs run by every once in a while, so woohoo. So that's our answer. Last thing we need to do is round for sig figs. If we go back over here, we see that what we started with was a 3 sig fig number. Our conversion actually had 4 sig figs. When you count sig figs, you consider it to be exactly 1 in the conversion is equal to that many sig figs. So this is a 4 sig fig number, so the least is 3. which means we'd round our final answer to the third sig fig, and we'd get 52.2 pounds. There you have it. All right, so let's try to find one more problem to do. And this one will do two things. This one will show us how to do conversions with squares or cubes in them first, and then also we can't do this one in just one step. We're going to need multiple steps to do this. So you'll see how we can string multiple steps of conversions together and how to use squares in conversions. All right, so we'll start out with 80.1 square yards. And the question is how we're going to get to square centimeters. So there's a few basic conversions that we can find. We know some conversions to begin with. I'll go ahead and write them in red up at the top here. We know that 1 yard is equal to 3 feet. We know that 1 foot is equal to 12 inches. And then we might need to find some other conversions here as well. So if you're looking on this, there's one really common conversion because we use it as the basis for showing the distinction or relating the English system to the metric system. And that's this one right here. 1 inch is 2.54 centimeters. And that's considered an exact conversion, meaning it's infinite significant figures. So it's actually, we've redefined the English system based on the metric system using that conversion. So we know that 1 inch is 2.54 centimeters. So that probably can get us there. Let's see if that's enough conversions to do this. Otherwise, we could always come back here and find more. There's really no reason you can't try a pathway, and if that doesn't work out, come back and collect more conversions. So we can go ahead and write it in. The first one, it's pretty clear which one we would need to use first because whatever conversion we use here has to have yards in it, and more precisely square yards. So we'll come use this one. It's the only one that has yards in it. 1 yard is equal to 3 feet. But that won't do it because 1 yard doesn't cancel a square yard, right? So what we need to make sure and do is square the conversions. And then if you square the top and the bottom, the square yard will cancel the square yards. All right, the next step would be to apply the feet conversion. 1 foot is equal to 12 inches. Again, we need to square the conversion to cancel the square feet. Now, the square applies to both the feet and the number. So it'd be 3 squared, 3 feet squared. So this cancels the unit, but not the square on the number still. It's still 3 squared as the number there. Same thing here. Now we can go inches to centimeters. 1 inch is equal to 2.54 centimeters. Of course, we would need to square that as well. Square inches cancels that, but the square still applies to the number. And we can go ahead and answer, and we've got our final answer in square centimeters. So we can work through just one at a time. 80.1 times 3 squared times 12 squared times 2.54 squared equals. So that would be 669.738. We would need to round to 3 significant figures. So that'd be 1, 2, 3. The easiest way to do that is in scientific notation. You could choose to do it like this. Well, actually, you can't do it any other way, and I'll show you why. Because you need to round to this place. Baby, we're making a video right now.
Please, I think I want to
No.
sit on your lap.
Okay, so then we got to round to that place. The reason we can't round to that place is because we would need to round this up. So that would be 670, and then we need to have all those zeros after it to keep the same size of number. But that's not a 3 sig fig number. That would be then a 2 sig fig number. So that's not going to work for us. So what we need to do is go ahead and count over and put it into scientific notation, and we can retain the 3 significant figures. 1, 2, 3, 4, 5. 6.70 times 10 to the 5th power centimeters squared. And that would be our final answer for this problem. All right, thanks for joining me. For me and also for Libby, happy studying.
Happy studying.